Hi there, welcome back to the channel. Welcome to the third video in the restoration of this Graetz Melodia 519. And alas, this is not the final video. Things went very wrong for a little while, and I had a lot more difficulty finding the issue than I thought I would have. And there are still a few things that I need to do when this video that you're going to see is over. So what did I have to do? Well, I had to sort out the FM because the dial alignment was completely wrong. I had to find the AM because it was completely lost. And that was the biggest mystery for me, because at one point I had AM reception and then suddenly, boom, it was gone. And that was pretty interesting. That had me looking at the schematic and seeing what should work, what shouldn't work, and which coil was gone. And then I found a part that was completely messed up. And being a hoarder, or on the way to being a hoarder, fortunately, I had a spare from a parts set that I'd kept in the garage somewhere, and you'll see how I applied that, and we'll check the result. Anyway, if you enjoyed this sort of thing, stick around, enjoy the video. But before I carry on, I want to thank the sponsors of this video, PCBWay. You'll find them at PCBWay.com, and they're the people I go to for all the PCBs that I use in my projects. But of course, they don't just do PCBs, they also do 3D printing, which I've used before to great success. They do CNC machining, sheet metal fabrication, injection molding, and a host of other services that'll take your project right from the beginning all the way to a fully assembled project, if that's what you desire. If you look at the list of products and capabilities, they've got a huge array of services. I'm sure you'll find something for your needs. And the 11th anniversary activities have started. Another opportunity for you to win some prizes and make your experience with them even more fun. I told you I had a lot of little things to do, little bits and pieces to finish, and I decided to start with the dial glass because I want to put it on. I'll be needing that for the alignments, and it doesn't look bad at all. I mean, look at it. It looks pretty perfect, right? Well, not quite. There's a little chip there, another chip there, and this is all the gold. It's all on the gold, so none of the lettering has been compromised. You see a little bit more on the top there where the that clamp goes that holds it onto the chassis. So I decided to start touching that up, and I've got some gold paint. It's not color matched or anything like that, but it's just a question of getting it looking better. And it's painted on the back side, so you just paint and then see what the result is on the other side. This paint that I use is pretty thick. It's artist's acrylic paint. Usually it goes on with one coat. Sometimes you need to touch up a bit more. And of course, that big one over there, which was the one that's sort of under a chip, you won't be seeing that one because it's actually ends up behind the knob, but it's always good to get it done anyway. Same with that guy over there. Just get it done. The fact that someone can't see it doesn't take away from the fact that you know that it's not complete. And finally, the last bit. That particular one needed a second go. I think when I started on that, the paint hadn't been mixed properly, so it was too diluted. So I gave it another coat. Okay, now that tape that goes over the top, that is there to protect the glass, and it's got this cloth surgical plaster, I think you'd probably call it. If you want to redo that, which is what I want to do, the trick is to just cut the top off, but do not try to rip that the vertical section, because you will rip that paint off completely. So again, just go there with the X-Acto knife, very carefully, just cut it all off, and do not touch the parts that are stuck to the back of the dial glass, because that will definitely ruin your day. And don't ask me how I know. Then it's a question of putting on some new tape. The tape that I've got is also this fabric. They still sell it. And I used to have the brown one, or the beige one, but now the only one I can find is this white one. So that's what I've been using lately. And it just goes all the way across the top. And of course you then bend it down, make sure that it's a nice, neat finish. And this one actually covers the beige one completely, so it looks better that way. I've just gone to the other side and just trimmed off the excess that came out the bottom. This is not strictly necessary because, again, you won't be able to see this. This will be hidden, but as I said before, the fact that you can't see it doesn't mean that you don't know it's not done properly. Right, now, the dials. The dials are both on there. As you can see, the FM dial has been redone. And I've put a little bit of felt on the top so that it doesn't scratch the back of the dial glass. And they've both been straightened into the proper positions. Then at the bottom where the dial glass rests on the chassis, there wasn't any foam there, but I decided to put a little bit of foam just to make sure that the glass is not touching metal. When you tighten it at the top, the last thing you want is for this thing to crack. So it's just a little bit of foam, a bit of super glue, and it might save your day. And of course the clamps at the top that hold the dial glass, they also came with this tape, and it's looking pretty wrecked. So I just put on some new tape, trim it up, and we're good to go. Just screw it onto the top there. I won't tighten it yet because I still have to put the dial glass in, of course. Just leave it in place. Ditto for the other side. And these two are now ready to receive the dial glass. All nice and freshened up and protecting the glass from the metal. And here we go. Very, very carefully. You do not want to break this. There's so many things that can ruin your day here that, yeah, you'll only know if it's happened to you. Get the dial glass nicely lined up, resting on the foam pads on the bottom. And then you gently pull the clips over the top and you now tighten them. And again, you've got to sort of angle it forward to make sure you've got the right angle so that the dial glass is at the right angle at the front. There's no absolutely correct position, but you'll get a feel for it. You can tighten a little bit and you can see there that it sort of goes down because it's forming itself into the foam at the bottom, but not too much. Okay, the knobs. As I said, these were all cleaned previously, so I didn't need to do much of that at all except for a touch here and there. And we'll put on the left knobs. These are single knobs, so both of them actually move together. They don't have separate functions like you do in some cases, but we've got that one done and the one on the right. And these have got these felt pads. It smoothens the contact between the knob itself and the dial glass. That's really good. And again, this one here, the tuning is also a single knob, single function. They literally move together. It's just an aesthetics thing. And the knobs are done. Now, as you can see, if I move the AM dial all the way to the right, it's in the correct position. And then the FM one is the same thing. And that just came about by experimentation, putting the dial glass on a couple of times and shifting it along the line. And that's it. We're done. We're ready for the next step. You know, I was just starting to set things up to do the FM alignment. I've done the FM RF alignment because I wanted to get the dial pointer right, and I did that just by adjusting the ones that I mentioned in the last video. So we know how that was done. And I wanted to do the FM IF alignment, and then I realized, why am I doing all this again? I mean, I've got to do this, but why am I filming all this again when I've got an exact replica of this radio in the previous video in which I went into great detail as to how to do all the alignment steps. So to do the FMIF alignment, I'm going to do it, but I'm not going to film this version. Unless there's something radically different in this one than we had on the other one. If there isn't, what you're going to see next is a clip that I'm removing from my own video on the Graetz Melodia 519 that I did previously. You'll see a few things are different, like the stand was still the old one, but the procedure is exactly the same. And as I said, unless something radically different happens, I won't show you the procedure on this particular chassis. Okay, let me go to the past and plagiarize myself for a while. Enjoy. I was just getting ready to do the FMIF alignment, which is my usual routine, which would have been to inject the 10.7 megahertz onto this, which is just a coil. I would normally just put it over the ECC85 and up the amplitude till I heard the tone. I would frequency modulate it with the tone, and that's where I would inject it, and then I would measure the voltage across the discriminator cap, the famous one that blew up or that shorted for me, and so on and so forth. Then I looked at the instructions and I got a bit of a surprise. See, a lot of this is actually pretty straightforward. They tell us to inject 10.7 megahertz. They tell us to set the dial on 100 megahertz, which is all the way to the left. No problem there so far. And then they tell us to detune these and then start tuning them. What you're doing here, these, you see this L94, There it is. So you detune it and you tune it again. L79, you detune it and tune it again. I normally don't even bother with this unless it was completely out of sync. If I couldn't hear anything, then I would do that. But what they're telling us to do, first of all, they're telling us to inject it into the grid of the ECH81, which I normally don't do either. I go straight to the beginning, and the beginning, right, the beginning of the chain is actually in the FM block. So it really starts over here. The signal is produced here. There's actually an IF transformer. There's a couple of coils that you adjust here, and then you have the first, where is it? Not this one, it's this one. The first IF, second IF, and on the bottom you've got the discriminator, or the ratio detector. So you would peak the top one, the top and bottom one, both of these, and then you'd go and adjust you would balance it with the ratio detector side of it, the secondary of that second IF. That's what I normally do. But then I check here and it tells us over here that you set the signal to the stator of the FM front end trimmers, point X. Point X, and I went looking for this point X on the schematic. I couldn't find it anywhere, but I'll get back to that in a second. So what you would do is you inject it to point X and you would peak these guys, 93, 78, and 79. So 93, 78, 79, and 94 is the null point. It's the one that you balance. And they've got this here. I hadn't even seen this. 1, 2, 1. And then, of course, you have to peak these guys as well. You would detune 33, and then you would peak 31, 35, 33 for a maximum. What does this mean? Well, if we look here, they tell us to set a, what is it? So 0 to 10 volts, which means you get a 10 volt voltmeter. They're saying microammeter, 100 microammeter with 100K in series, blah, 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 blah. And this is the null point. And this is where I hadn't seen this at all because I hadn't been paying attention. Let's look at the schematic itself. It tells us a bit more. You see, if I had paid a bit more attention and I looked at the schematic more carefully, on this part of the schematic down here, it actually tells us exactly what to do. There are 2 points at the back, C and A, 2 little sockets, and those guys are pretty easily visible. And what you do is you are going to do all the adjustments by measuring at these 2 points, these 2 little sockets. So you don't actually go inside and look for points to measure from. They're all accessible here. And here's the first one. There's A, and you see that from A, it comes down here through 100 microammeter, through a 100K resistor to the chassis. This is just a voltmeter. So you just put a voltmeter across there and you peak it for the maximum voltage. Very, very simple. And where is point A on the schematic? Well, point A is actually this point over here. You see, you're measuring the voltage across that discriminator capacitor, the one that I replaced. You're literally just measuring the voltage across that. As you peak the IF circuits, that voltage goes up. And there's ground. So if you're measuring between point A, which is here, and ground, you're literally measuring the voltage across that capacitor. There's no big deal, no mystery involved. And then they tell us that we have to put these 2 resistors in series from point A to ground. So 200K resistors in series to ground. And you measure with a microammeter, 10 microammeter, from point C to the junction of those 2 resistors. Well, this I've done before. I actually made these 2. This is a 100K resistor, 2 crock clips. And I would normally clip this across that discriminator capacitor and measure from there to another point, which we'll see in a second. So I've already got this. Point A is the same. It's across the capacitor, as you can see. So it's from the capacitor to ground, literally across the capacitor. And you put your microammeter there at the junction of the 2, and you go to point C. Now, point C, if I followed it through the chassis, would come to either here, probably not right there, but probably somewhere here, probably after the 100K. I'm not sure. It doesn't make any difference. All you're doing is you're balancing the 2 diodes in the ratio detector. It's exactly the same way as I've done before, except this guy makes it really easy because it literally gives you 2 sockets to work with. And the ones you adjust are the FM ones. So 93, 94 is the balancing one, the one for the null point. And what you need to do is make sure that you get 0 current. This thing will usually use a center negative or center 0 meter. So as you adjust 94, it'll go positive, and then it'll go through the 0, negative, and you try to balance it right onto the 0, okay? Now, what do we adjust? We adjust 93, 94 we balance. We adjust 78, 79, so that's the first IF, and again, you're just measuring the voltage on there. And then you go down to, or you go back to the front, and the front is 31, 33, and 35. So it's these guys over here. These others have got to do with actual RF alignment. And they actually tell us where point X is. You see, they tell us to inject it at point X, which is there. They show us point X. And there's actually a little hole there where you put a little wire in there and inject it into that hole, which is absolutely great. Now, where is this? This is the stator of C12. Why are we doing it here? What I usually do is I capacitively couple it to the tube itself by wrapping wire around the coil, rather around the tube envelope, and injecting the signal that way. They're going one step further. They're telling us to put it on that point there. Now you see, this is the oscillator section. This is the RF front-end amplifier, and this is the oscillator section. So what they're telling us to do is put it on here, and by putting it on this point, you are injecting the IF signal, the IF frequency, in a way that doesn't affect the balance of the actual oscillator circuit, and it's the best place to send it into. So you're sending it through here, it's coming out here, then you're adjusting these guys over here, 31, 33, 35. That's the coupling that you are adjusting to get the signal 10.7 megahertz into the IF chain, the normal IF chain, which is over here. It starts at the ECH81. That would be the signal coming into the switch between FM and AM, which is perfect. It makes it a lot easier. So that's what I'm going to do. Okay, I've got things set up. I've got the signal generator connected ground to the chassis over there. The signal comes in here through the little wire to that X point over there. So the signal's going into the point which they indicate we should feed it into. I've got this on FM, obviously. I've got this set to 100 megahertz, which is left of the scale. That's all according to their instructions. My multimeter is all set, ready to go. It's on the 10 volt scale. It's going to be reading minus DC volts because that's a negative voltage that indicates the strength of the signal. And I've got it coming through my multiplier set to, I think it's 5 times at the moment. I'll adjust all these settings as I see fit. I've marked A and C on here. The first set of adjustments, I will use the multimeter, connect it to point A and just peak the voltage. And then at the end, I'll come and do the balancing act with which uses C. But at the moment, this is it. This is the meter coming to the back of A and ground to chassis. So I think we're about ready to go. I'm going to do this one and the bottom one. That is, what is that, 78 and 79, I think it is. Yeah. This top, the bottom one is 94. That's the one we need to balance, so I'll leave that out. So let me do these 3, and then we'll move on to the front end, and I'll show you which ones to adjust there. So let's look at the meter. I think you can just see all that. So let's try it. This one here. Very little change, but it's peaked. Try the bottom one. Very little improvement. Very little. It seems to have been quite well aligned. This one. Well, that didn't need much, did it? A bit disappointing. You always like to see a massive change and know you've improved things dramatically, but this is not the case here. So let's see what we have to do on that one there. They tell us to detune 33, which is that guy over there. And then they tell us to peak that one, and then peak that again. So if I detune that, and then I peak these guys, there's no difference. It's practically perfect. No difference. And then peak that. And that's it. That's all the peaking done. Pretty simple. Have I forgotten something? No. All I need to do now is to balance that guy up there. Let me show you how I set up the meter for that. Do you remember what they told us to do? They said connect two resistors in series. Here we are. Between point A and ground, which means from there. I'm doing it on the underside because there's some clips there. And I'll just use this as ground. Now they tell us to connect the meter, the microammeter, between point C and the junction of these two. So point C is that guy over there, and I'm doing it on the underside again. There's one connection, and the other one goes to the junction of these two resistors, which is over here. And across those two ends, I've got to connect a microammeter. Now, I've got something you may not have seen before. This is a meter I've owned since high school. I remember asking my dad for a multimeter, a simple, cheap multimeter for Christmas, and he went and bought this one. It was a very good meter at the time, and it still is. Now, what it has is it's got some very good current ranges. There's all the current, you know, 10 amp, 500, 110 milliamps, 100 microamps, and I've got a 10 microamp range. So that is what I set it to. In fact, I start off at 1 milliamp, just in case, and connect that in there. Now, this is not a center zero meter, unfortunately, because it should be something that starts in the middle there, and then you can go negative or positive and make sure it goes back to zero. But what it does have is a DC reversal switch. So when it goes down, if it's coming down and it's going into the negative range, I just reverse it and it starts going up again. So that's what I do. And let me see what happens. At the moment, we're on 100 milliamps. 1 milliamp. 100 microamps. This thing is pretty much zeroed as it is. It's pretty much set as it is, but let me increase the signal strength just a bit. See if I can get some deviation. Yeah, I do get a bit of deviation. I've increased the signal strength just basically to give you a demo of what happens when we adjust this. Okay, I believe I've got it there. Let me try and show you this at the same time. See, it goes up, goes down, goes the other way, so I can change this. If I keep going down, or rather up, I think you get the idea. The idea is to get it to stop right there on zero. That is perfect, and it was pretty much spot on anyway. This is on the 10 microamp range. That's as accurate as you're going to get. And I believe our FM alignment is complete. The IF part of it anyway. Good. That is a lot more difficult to explain than to do, believe me. Now that we have the FM sorted out, time to address the elephant in the room. The AM, or rather the non-existent AM. But there's something different here. Maybe you've noticed it. There is no elephant in the room, or rather there is no coil that was creating the issue. That one over there, this is a coil or double coil similar to that one, and it's gone. I've taken it out, and I'm going to explain to you what it is I found, why it is I found it, and what I'm going to do to resolve it. Hopefully, just completely fix it up. Let me start from the beginning. We're back to the schematic, and I want to show you why. You see, when we look at the top of the radio over here, this sketch or this drawing tells us a lot of what we need to know. If we look at the top of those switches, or rather the underside of those switches, we see those cores or the coils and the trimmer capacitors at the bottom. And the one we're looking at is this one over here. This is the one where the wires had been ripped out. And I don't think this was my cat. At first I suspected, when one of you mentioned it, I suspected it might have been the cat. I considered creating cat stew, but then I realized, no, someone had been in here and did something really weird. These were ripped out. One of the wires from this guy was wrapped around that little capacitor. And this one here was also sort of interlinked with that. So we're looking at coil 41, coil 39, and capacitor 43. Now let's go back to the radio. I'll show you where they are and where the one was. There is 41, or that's where 41 was. There's a little capacitor. It's one of those little weird ones that you can unwind to adjust, and that one is 39. Now, the wires from this guy were interlinked and interwound with the wires from that one. One of those was wrapped around this guy, and I was getting everything on, or all the AM bands, with the ferrite antenna on, which was the strange part. But if we look at the schematic, it actually makes sense. But before I go to the schematic, let me tell you what I did. I removed that guy completely because its wires were unwound from the coil and sort of wrapped all over the place. I wanted to see what I was doing here. And then I checked this guy and made sure that the wires were in the correct place. I checked that capacitor, made sure that it was in the correct place and that nothing was unwound or that it wasn't shorted or anything like that. And I took that out because I wanted to see what was wrong with it. And what I found out was, well, a little disappointing. You see, this is what I took out of there. Now, these were wound over the top, not the way I've done it now. I've tried to neaten it up. This has got two coils in here, one here and one here. This thing is, I believe this is the primary, this is secondary, and I'll show you in the schematic in a second. These two were in place. No, these two. There were two wires here. Here's one, and there was another one coming out of the bottom, and I checked for continuity, and this one had continuity, but this one only had one. The actual other side of this coil had been broken off from, I believe, this point over here, where it comes out of the bottom of the coil. So there was no way this thing was working, and I don't understand what they did to resolve some of that. I really do not. I can't answer it because, again, as you probably saw, it was working at one point, and then suddenly it stopped working, and that's when I thought the cat or myself had ripped some wires off. So anyway, I decided to try and fix this. I tried to separate these wires. I rewound this thing like this. You know, I did that. You'll notice there's only one now because in the meantime, I broke the bottom one. I rewound this, and then I rewound that one, trying to sort out where the wires were. Both ends of these actually go to ground if we look at the schematic, and then this goes to the one end, this goes to the other. But I could not find a way to get those wires, that wire from the bottom. I can't see where the break was. It's sort of underneath there. So I thought, well, what I'll try and do is remove this from this core, from this former. And I did, in fact, remove the ferrite core from the inside, thinking I'd be able to somehow pull this out, look on the underside, see if I can't find the end of that coil, unwind a few turns, and put it back. I couldn't do that. This thing has got glue, some sort of glue. I tried all sorts of things to dissolve it, and I thought there's no way I'm going to do it. So I thought to myself, well, let me go look at the schematic and see what it is that this coil is doing. And it got interesting. Let me show you what I mean. This is what we're looking at. And if we take this from here, we take the signal from the antenna. It goes in there. It goes through there. That signal comes through here, goes through there. This C is shortwave. So when you select shortwave, it clicks up there, and that goes to ground. So the signal is induced. If you see that goes through there to ground. So it's induced across that coil. It's then picked up by that coil, and you can adjust it there, and it goes to the input selector. The input being the input to the ECH81. In other words, the front end signal selector. Okay, so this should have worked all along because it has nothing to do with these coils down here, 39 and the culprit 41. Okay, so that wasn't an issue. Shortwave was working. All right, should have been working. For some reason, I got nothing when I got back there. And then if we go one step further, we select medium wave. And if we select medium wave, what happens is the signal is no longer shorted to ground here because that sort of goes to there. Okay, that switch is open. So the signal carries on down here, through there, through there, through there to ground. Okay, it goes through the one part of coil 39, which, as I showed you, is that guy over there. It then goes through the one part, the primary of coil 41, which is the bad guy. But there's a short over here. So in one of these positions, this coil 41 is completely eliminated. It's not used at all. Here, what is that? E. E is long wave. So this is a switch on the long wave stack, and it's normally closed. So when I hit long wave, it opens. In other words, this coil over here, this one over here, is only for long wave. So if I select medium wave, this signal is only induced across 39, and it's shorted to ground, so this one is completely out of the circuit. Which means that if I remove this completely, provided all the wiring here is correct, I should be able to get shortwave, medium wave, but not long wave. And I was almost ready to accept that because, as you saw in the opening shot, I removed this coil completely. I removed it completely. And I was prepared to accept that I wouldn't have long wave. It's not a big deal. This belongs to a friend in Lisbon. There is no long wave. They don't get any long wave in Portugal. I mean, I get some from Morocco, and I get some from France, I think it is, and I get BBC4 still. But in Portugal, nobody really listens to long wave. And I was ready to accept that. And then I thought of something. This long wave coil is probably something I can find a replacement for on some of the radios I've got, or some of the chassis that I have as spares, sort of parts chassis. And I found one. Let me show you. Here it is. Now, is it exactly the same? No, it's not. It is definitely not. But I think this is going to work because both of these coils have continuity. I think I've determined that that is the low impedance one, that's the high impedance one. So I'm going to put this in the place of that one. And I'm going to see whether I get my functions back. And I think it's going to work. This is the long wave coil of the long wave front end coil from an old, God, I can't even remember what brand it was. I think it was an Multimeter. And I may not be able to peak the input. In other words, I may not be able to optimize the reception, but I'm hoping that I can get everything else to work. And I've put these two together because these two do go together, and then I'm going to solder this one to the one end where the other one went, and this to the other. And if necessary, I can invert those because I'm not sure which one goes as the primary and which goes as the secondary. There is no way I can measure the inductances on these because now I've broken, well, one was broken off already and the other one I broke off. So I can't measure the inductances to check what these inductances were. This is just a front-end tank circuit. The result is, well, I might have to change the capacitors that go onto that tank circuit. More specifically, capacitor 40, which in the schematic says 50 picofarads, and capacitor 43, which is the trimmer. So let me put this in and see what happens. I mean, how bad can it be? We might end up not being able to pick up long wave at all, but let's give it a shot. And there she is. It's in place. I haven't actually stuck it down yet. I've just put it into the hole. The two that are connected to ground are over there. And then this one goes, the top one goes to there, the bottom one goes to there. And I had to put these little wires to extend them. But when we test it, hopefully we'll get some good results. Right, folks, here's the deal. I've switched it on. I've got it on shortwave. And I have to admit something. I've already tested this on shortwave with the coil out. So I knew it worked. And it works. And last night, this is morning, so very little on shortwave, except a little bit here on the high frequencies. But this works perfectly, right? No surprise for me, but I just want to show you that it works. I'll put it on medium wave. Say goodbye. Canary Islands, it works perfectly. Now the one I haven't tested, I'm telling you, I have not tested it, and it's not just to create suspense for you. Sometimes I need suspense to keep this interesting for myself, is the long wave. And I'm going to click it on long wave. Now that I've got the coil in, long wave, let's see if we get, well, very little. There's something up here, I think. Ah, there we go. That's the one station I get during the day, and it's receiving. something else over here, I'm not sure what. So, that idea worked. What can I do to check the alignment? I'm going to do a full IF and RF alignment, but I just want to see something. I'm feeding the antenna with 200 kilohertz with a tone modulated on it. And what I'm going to do is I'm going to see if I can strengthen this a bit. We can hear it. Yeah. Wait to lower the volume. Let's try the other way. It's much, much weaker, so I'm going to go in and peak it. I've had to lower the volume again because it really is getting louder. Getting weaker. Ah! I think I've peaked it. Brilliant. This thing's working well. So what have we achieved here? Well, we have made sure the shortwave is not affected by this cock-up of coils that was here. We know the medium wave shouldn't have been affected anyway. And so obviously there was some mix-up with these wires that they had here. That was cutting the medium wave. We've got the medium wave back. And we've got long wave, for what it's worth, in Portugal. So this thing, I'm going to stick this in place, and I think we've got everything functioning beautifully, as it should. I thought of swapping these around, but I don't believe that was incorrectly wired. You see this top here is the primary. I think that's the primary, and that's the secondary. I checked the other coil, where the other coil goes on my other radio, because I wanted to see where this lightly colored one, what I think is the primary, should go, and where the secondary should go, and I've made them go to the same places. So I think this is working exactly as it should be, and I am a happy camper. I'm a really happy camper. Sometimes being patient does pay off. So now we've got to do the IF alignment, the RF alignment, and again, because this is identical to the other radio that I did, I'm going to cut back to the previous video for that section. And unless anything is different, you'll be seeing the IF and the RF alignment of the AM bands on the previous model, not the previous model, the other version of this radio that I restored. I think it was about a year ago. All right, let's cut back. Well, I think I've got everything ready to do the alignment. I'm going to do the AM IF alignment. And what I have is I've set the signal generator to 460 kilohertz, which is the IF frequency. The amplitude is set to a minimum. Modulation, 30%, a 600 hertz tone. And it goes to my pi attenuator, my switchable attenuator. I'm leaving it at 0 dB attenuation for now. And it then goes through the little socket that I have for the ECH81, which is connected to the grid, which means that I'm ready to go. And I've got the multimeter, my Simpson, connected to the output of the speaker. So if we put the volume up, we can hear a tone. It's probably too high, so I'm going to give it 12 dB of attenuation. Yeah. I don't want this too high. Volume's on max. But this is... Actually, I've just had an idea. Let me use my... Hang on a second. I want this to swing higher without putting the volume so high that it blows our ears out. So I'm going to use my multiplier here, which I did in a recent project. And we'll get it to see how that works. So the input is in here. I'm going to set this to off, so 2 times multiplication. It's going to double the voltage, AC voltage in this case. It's just measuring the speaker output. And I'm going to switch that on. And I'm going to put the volume up. Yeah, that's going nicely, but I still want to give it a bit more. I'm going to give it 5 times. Okay, that's good. So I don't need to put the volume on max, but I can also just put it on, can you see that? That's a good swing. And I'm going to put this on dummy load so I don't have to listen to it. And now we just watch the meter and I'll tell you what I'm doing on that end. Okay, I'm going to start with this guy over here. It's the one closest to the antenna inputs, which is, just to make sure I've got that right. So the IF transformers for the AM are the, as we're looking at it, the right-hand side, bottom and top, and this one, bottom and top, the right-hand side. So let me start here. Oh, that is going up. But there's a massive peak there. You see, I can't hear what this is, and I'd rather hear it. Even if I put the volume lower, I'd rather hear it. That's very sensitive. That's a peak. Let me put that there just to try and adjust it a bit more. That's very, very sensitive. Okay, that's the bottom IF transformer. Now I've got to do the top. It's going to be difficult to see this, but I'm going to try and see what I'm doing here. This is very, very sensitive. Okay, that seems to be a peak. Let me do the other one. Okay, and now the bottom one. I'm just going to see if there's another peak here somewhere. No, there isn't. Okay, that's the IF transformers. That's the IF chain corrected for 460 kilohertz. I'm going to do this again. Put the volume down. I'm going to do this again because, as you saw there, this thing's very, very sensitive, and trying to do it while looking at or speaking to the camera and looking at the meter is not easy. So I'm going to just do a final adjustment, really peak it up nicely, and then we'll see just how it receives on AM. That is picking up very, very well. That's the long wave, one station I get. Canary Islands. And that, my friends, is where I'm going to leave you for now because, as you probably remember, I said I wanted to finish this restoration in just this one video, another one video. And it looks like I'm going to have to do another one because, as Mr. Burns said, the best laid plans of mice and men often go awry, and this one definitely did. I was not expecting that mess up with those coils. Certainly wasn't expecting to switch it on and suddenly not have what I had before. In other words, no AM. So getting that back took a lot more thinking time and energy than I was expecting. So what do I need to do on this radio? Still, I need to change the filter caps. I haven't even done that. And the selenium rectifier. I need to put Bluetooth on here. I need to do an RF alignment for the AM, which is I need to do very carefully. I don't want to rush it because obviously because we've changed the that front end coil, it might affect something. I might be able to squeeze a little bit more out of this. And the IF was really very, very straightforward. There was nothing completely off, which is, you know, something that I wasn't expecting anyway. So I'm going to leave you hanging for another week, I think, and get back to you finally. Again, another plan of mice and men. Do the final video next week, where this thing is going to have Bluetooth and be put in the cabinet and do some testing with the royalty-free music and test the medium wave transmitter that I built with this thing, because the sound should be astounding, should be amazing. So that's where I leave you. And I do hope you've enjoyed that. And if you have, big like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon, PayPal. Links are in the description below. So once again, thanks for watching, folks. Bye for now. And most of all, stay sane.